Okay, welcome everyone to my new lecture where we are going to learn about Kirchoff's current law. At any node in an electrical circuit, the sum of currents flowing into that node is equal to the sum of current flowing out of that node. Let me first show you what is a node. A node is a point where two or more circuits meet each other. So, for example, you have here one circuit and now you have here another circuit. So this here is a node. You have to have two or more circuits, so you will have a node. Here you don't have a node because this all is one circuit. But if you have two or three or four more circuits, I don't know, like this, here you have a node, and so the sum of all nodes coming into the sum of all currents flowing into that node must be same as the sum of all circuits going out of that node. It's like when you have bread, and I don't know, you cut it into half, you have the same amount of bread, only it's just cut. It's cut right here. This not cuts the currents, but you have the same amount of current flowing into this node and flowing out of this node. So I must be equal to all the sums of currents flowing into that node A. So here we have an example of doing calculating currents with Kirchoff's rule. Okay, so here you have a circuit, and let's start doing this example. Here you have a node A. So you have here one circuit, 2, 3, and now you will have, you know, four different currents. Here you have I flowing from here to here, and it's, you know, separating. Here you have current I1 going here, I2 in the middle, I3 in here. In this is going through the resistor R3. R1 is 1 ohm, R2 is 2 ohms, R3 is 4 ohms. The voltage of the battery is 10 volts, and we have to calculate what is the current flowing, what is the amount, what is the current I. So we have to calculate what is the current I. Okay, so we have to know some things in the electrical circuits. From here to here, what is the electrical difference potential? From here to here, you have electrical difference potential that is equal to 10 volts. Why? Because what is an electrical potential difference? That's voltage. The voltage from A to B is same from here to here, to here to here, and from here to here. You should, remember about ions. You have here, I don't know, plus, and you have here minus. So from A to B, look, so the voltage U, A, B is equal to U. Why? Because A is the bigger potential, the plus, and the B is a minus. The voltage looks from the minus to the plus. So for here you have B is the minus and A is the plus. You go around here and and see the voltage over here. You also looks from the minus to the plus. You go around here, so you have it. Electrical potential. The voltage from A to B is equal to this voltage of this battery, and that's 10 volts. So from here to here, you have from here in this direction you have the same amount, the same voltage, same electrical, different potential. From here to here you have the same, and from here to here you also have the same. So it's easy to calculate I1, I2, I3 because we know what the resistance in this circuit is, and we know the resistance here and here, and it's easy to calculate I1, I2, I3, and later on we'll use the Kirchoff's rule for this node A. See, here, you have it here. I must be equal to I1 plus I2 plus I3. Here's a definition. So, let's calculate I1. I1 is equal to, we use ohms, the voltage A to B divided by R1. See, the A is higher potential, B is a smaller, lower potential. Current goes from A to B, so we don't have to put the minus sign. You use minus sign when the current is going from lower to the higher potential. But voltage looks from the lower to the higher potential, and you know, going like this, it's the same voltage and it's the same direction as this voltage. So from here to here you have the same voltage. And okay, that's now 10 volts divided by 1 ohm, and that's 10 amperes. Okay, now I2 is equal to electric potential difference UAB divided by R2, and that's 10 volts divided by 2 ohms. Because R2, the resistance of this resistor 2 is 2 ohms, and that's 5 amperes. I3, same story here, UAB divided by R3, and that's 10 volts divided by 4 ohms. Just move these sponges, and that's 2.5 amperes. So now we can calculate what the current I is with Kirchoff's rule. See, in this node only I is going into the node. So in one place we put I is equal to all the currents flowing plus all the currents flowing from out of the node, and that's I1 plus I2 plus I3. And now I is equal to I1 is 10 amperes plus I2 is 5 amperes, and plus I3, that's 2.5 amperes. And you get I is equal to 17.5 amperes. Let me just see, is that correct? Yes. So, thank you for watching. I hope you learned something. Please click share. Please share with my video. Click like and subscribe onto my YouTube channel. Thank you for watching, and I'll see you in my next lecture.